so I think we are almost at the end. Okay, so we will try to be not only quick, but for today we decide just to compact a little bit, since some of you have to pick up planes. Actually, myself too. Okay, so I think it's important to try to compact a little bit the previous agenda we had. Okay, so the wrap-up discussion we have in the first session, we're gonna move it to the second one. Okay, so with that, we expect to win some minutes. Okay, so let's see if we can finish around 5. Okay, we will be doing still the coffee break. Okay, and and I will try not to extend myself, so I would say just welcome, and that's Bram, okay, from Semtech, who is one of the full members of the BDTA, and is chairing the working group of ontology. So thank you, Bram, for taking the lead. Thank you.
Thank you very much, Edward. Thanks very much, everyone, for being here. As Edward said, my name is Bram Bazuin. For those who haven't met me yet, I work for Semtech. It's a consultancy and software developer in interoperability. So kind of related to what we're doing here today, what we're discussing here today, mainly on the intersection between standardization, information exchange, and implementation in software, so that actually end users, rather than just academia, are able to standardize the information they're actually working with day to day. And for me, for us, this is the common theme of today. So for those who were in BDTA in April, or also for those who weren't, what we did there is we went over some projects and some initiatives where ontologies were formed or developed. And what we saw, basically our conclusions were that while everyone's looking at ontologies and developing their own ontology and using semantics to do so, and in theory standardizing things, what we felt that was lacking was actual interoperability and standardization in practice. So there's several sets of ontologies to standardize the way you represent the building. Same thing for sensors, same thing for everything, same thing for permits. But this way you just end up with a bunch of standards, right? So how do you ensure these standards are used and we actually benefit from those standards? Because that's the point in the end, or it should be the point in the end. And important conclusions were that, well, first of all, it's really hard within the buildings and construction industry and the digital twins to actually find ontologies. Right? If you're a researcher, you will find them, you will know them. You can Google, you can go to Google Scholar and read some research papers on it. But how do you actually find data that tells you this is how a building is composed, and this is how a sensor measures, or how we represent that information? So one of the main conclusions of that workshop was, well, what we need to do as Building Digital Twin Association is to build a catalog that at least allows creators and users of ontologies to find each other and to make known what their ontology has as a purpose, what it's able to do, how it's structured. I have to stand behind the desk? I didn't want to hide myself, but I'll do then. I guess it's for the people online. Welcome to you too. So, they're very serious about that. So I won't move anymore. I'll try not to. So rather than BDTA just being an initiator for the industry for standardization in digital twins, we're now actually going to facilitate that. And what we've started doing, and I won't try to spoil too much because one of our presenters will present the progress on that, is to set up an ontology catalog where you or we are able to submit our ontologies to BDTA that relate to building digital twins and are able to state where they can be found, how they are to be used, what the metadata is, and other people, users of the ontologies, are the ones who can find it. And today we will continue basically there and also look at some other initiatives and projects that have been going on. And we'll look at the status of this development and how this helps the creators of ontologies, the implementers of ontologies, namely software developers who build a tool that's used by end users, come together and actually standardize their information together. Now, as Edward stated, we will try to condense the program a bit because some people stated, or many people stated, there's no presentation on the screen right now. They have to catch a plane. So what I propose that we do, or what we're going to do is, we're going to skip on one of the discussions, the pre-break discussion, continue a few minutes into the break, then we do hold the break, so if you want to leave or hop over or want to drag other people in, that's still possible before the second part of the session. And we'll continue there, and at the end we will discuss on the findings and the conclusions we found in each individual presentation, and try to form an aligned vision and determine the next steps that we should take together in the research that we need to be doing. So again, thanks for being here. I'm looking forward to learning about your work today, and I will try to make some bold statements to discuss and challenge the speakers. Very first one today is Judith Valth. Thank you, Judith.
Yeah, thank you, Bram and Edward and all the BDTA people to inviting me to this session. Thank you very much, and I'm happy to be here. So my topic is about ontologies and building permitting from a domain expert perspective, I will say. So I am not an ontologist or a technician or computer scientist, but I'm very, very keen on building permitting, and I have been involved in some project and initiative which is about ontologies and building permitting, and I would like to give you an overview what I have been involved in. I have to run through the slides, I have to admit, but I hope it's good enough for an overview, and you're all very, I would be happy if you can contact me afterwards if you have any questions. So the intro, just to understand, so this is my focus. And from there, I'm looking in different direction, decision-making, process analysis, and so on. And one part is ontologies. So if you would give me something else, I would be happy with that. So because this is what matters to me. But so to understand what I'm talking about in the next minute, so it might be good for you that we have a common understanding what the building permit process means. So this is just a schematic overview on the let's say the process within the municipality. So it consists of different processes, a formal review and assignment, participation of other agencies and other municipalities even. There is a compliance check for the content and so on. So just an excerpt and a schematic overview, but we will get back to that just to let you know. And for the ontology work where I have been involved in, like the ontology development, not the alignment yet. So we developed this taxonomy for a building permit system, which is pretty much more or less the same intention what the BDTA has, because we don't speak the same language. We have so many stakeholders within our domain, and we maybe even do not understand each other. So this was like a first intention to describe the building permit system on a high level, let's say, with it consists of different subsystems, technological, procedural, but also organizational and legislative. You can check everything online. There's also a paper published about this. Then for the, that's not working, but it should actually say something about the OPPA, which is the ontology for building permit authorities. And in this little box, that should actually be the assignment. So which officer is actually suitable for a specific building application. Different countries handle that differently, so they divide in complex buildings, smaller buildings. In some countries, you have special qualifications and competencies you have to achieve before you can check a specific type of building. So in this ontology can help you with the process, so to find the most suitable officer, which is flexible enough to cover also some local requirements. Let's say, for example, if they would probably say in our city, the western part is covered by this officer and the southern part in this officer. So, but also many, many more other examples. Same ontology, but it can also cover the participation process. So I mentioned there might be other agencies involved in the process. For example, if it's, I don't know, a nature protection area, like a forest or something around, maybe depending on how far it is away. So you might have to involve other agencies, or if it's in a historic building or monument, you have to involve the preservation authority, or maybe also, for example, in Germany, there are also some specific structural engineers you have to involve if it's a public building, for example. Endless scenarios, and we try to cover that, for example, also with some rule-based things with a DMN, like decision notation modeling, and so that you can see, for example, if your public building is more than 1,000 square meters, then you have to involve this specific engineer, for example. But now, more importantly, the alignments, so how we can align the different ontologies for building permitting. So together with some colleagues from Bochum and Weimar in Germany, so we had the idea that we could actually cover the process, which I showed you before, with different ontologies. So we, as I told you, the assignment and the participation could be done by the OPPA, and the guys in Bochum, they had developed this IDDO, which is now called isoprops, by the way. So, and they could check specific information requirements within data structure, building data structure, where we could cover content review. So, and we try to align those, and then, but, oh, this is not working. This is a little unfortunate. No, it's the entire picture. I will try to explain anyway. So you see, this is just like the 3 parts, and then the advanced one is that we also cover this part and this part, so that they're also more related to each other. So once we get like the information from the application, so it will be forwarded, so that will initiate the other processes until the very end, and it also will include the notification letter and the report, whatever the decision is. We also used information, ICDD information containers for this, and we are like the advanced, so this version is available, which was published at the EGIs last year, and the new version the advanced version we will publish, or will be submit soon. Doesn't mean will be published. Anyway, so there was also, okay. So there will also, maybe we can skip that even. So it was also like a different layer structure on how to check the regulation for which part of the process and which will be initiated. Okay, it will get better, so no worries. Not sure what happened. But we can just skip that. I think I talked enough. Then we can continue with the rest.
All right.
Sorry, I didn't notice.
I stripped the image in the upload. From what slide? From here?
No, it's just, we already like, no, it's not there. That's weird. Yeah, we can continue with this. Yeah, it's fine. Thank you. So yeah, that was about this onto PPR. We call it like an ontology for building permit review. With some colleagues from TU Berlin, we had another exercise, let's say, which is called BESI, Built Environment Thesauri Ontology. So because Isabel Fitkau, the first author here, she had developed an ontology on fire regulations, for German fire regulations, and we were wondering if we can align that with the onto PPR, which we have, the alignment we have developed before. So and then we have a few scenarios, like from the process perspective. So it either could be a part of the participation when we have to involve other specific fire engineers to check, to double check the fire regulations or the fire concept. But it could also be part within the municipality alongside with isoprops or IDDO to cover specifically fire regulations in more detail. And Timo Hartmann, he will present this paper next week at CIB W78, by the way. And so yeah, this is just a short overview, so which concepts are related. We used a SCOS, and this is the workflow, how we could actually, we were wondering, maybe it's actually the same message as the BDTA has, or the question. So if we know, if we want to develop something, so how can we even know that is something already available, and how can we also align with this? And this is like the first draft, the first workflow where we see it. But I want to show you a little more. So another ontology alignment, which is a little bit out of the scope from the process scheme I have mentioned before. This is the OPPI. I know it's not so creative, but anyway. So this is about the building permit inspection, so which is happening afterwards. And as you may know, in different countries, different regulations on inspection. So some countries, they do not really do inspections on site, on the construction site, and in some countries, they do it like every 2 hours or so, in worst case. And we were trying, so this is like an additional part. And we are, it's again a little unfortunate, but let's see. So this OPPI is actually a combination of this OPPA I mentioned before, like the assignment, so also to assign specific inspectors, because this is relevant for the process, but also ontology developed by Sebastian Zayas. This ontology is about inspection planning, so how I can inspect or plan inspection more properly. And the Decon ontology by Yuan Zheng from Finland, and he had developed Decon ontology, which represents more or less the construction activities itself on the construction site. So this is not working, and let's see. Yeah, and then my project, what I actually do in Cambridge is, it's related to roads, and this is how, so imagine we have roads and we have buildings and cities where we need building permits for, and the idea of the process is that we can use information from the road digital twin in best case, or maybe in future, and also vice versa. And what I'm doing now, so I do a lot of research on this part, and I'm keen to understand what information I could actually reuse for the other one. And my colleague, Mentyeng, he is developing the National Highway ontology in the UK. And as you know, I developed or co-developed this OPPA, and now we are like in the first step investigating how we can even cross-domain align different ontologies, maybe starting with this participation process, meaning in some, it's also depending on the country, but for example, in Canada, it's quite clear that they say if a highway is more than 100 or less than 180 meters away, so then you have to involve in a specific transport agency. In other countries, it's more discretionary, but so this is the way we want to explore that a little further. And last but not least, we are also doing a scientific review. Jeroen is part of the team, together with Emma, Alex, and Ruben. So we are, from a scientific point of view, we are trying to understand what ontologies on building permitting already exist. And so we had a few keywords we are looking for, and we are now doing the review and sort out which are relevant and maybe not. It's not that easy, I have to say. And what we are thinking, which we can up with, I mentioned it's still ongoing, so that we have like a process map, maybe a little similar as before, and then that we can link, okay, and this reference relates to this part of the process. Maybe this part covers maybe more high-level ontologies. So it should go in this direction, but from a scientific point of view. So thank you.
Thank you, Judith. We have time for one question.
This national digital, or this ontology for the UK, I understand is part of the national digital twin program.
No, I mean, no, I think this is like the National Highways UK. It's an institution who owns and facilitates highways in UK. I hope I'm right. So, and they have like some documents, and my colleague Menting, he is like developing based on this documentation and on ontology. So, yeah.
Well, in Netherlands there is something similar, might be, with Big Waterstaat, with coins and coins too.
Yeah, there is, and there are many lessons to be learned from the first two versions. Yeah, let's speak about that one later.
Okay, perfect.
Thank you very much. So we've seen here from a user perspective or domain perspective the use of ontologies, and now we're off to Jeroen Werbroek, DigiChecks, who will share some insights on well, the developments in DigiChecks. I'm not going to spoil any more for you. And I just validated that all images, in fact, are still in the presentation, so that's good. Jeroen.
Hi, thanks. Maybe I'll sit down while talking. So yes, good afternoon also from my side. For me, it's like Bram said, this presentation is about the DigiChecks project and the high-level ontology that's working there, but also how the complexity of ontologies or of rule validation, rule checking can be hidden away from the end user in a way that also non-domain experts can start using and can start developing requirements, regulations, but yeah, this could be permits, it could be project requirements and so on. So the idea is to have, to lower the threshold. I'm Jeroen Werbroek, I work at Ghent University. I finished my PhD last April, and the main topic was the use of semantic web technologies for federated common data environments. So it's a bit related, at least, to this. And now, a few weeks ago, I joined the DigiChecks project. So I'm also, it's also exciting for me to be able to tell about it. I hope I don't make too many mistakes there, but let's see. So the DigiChecks project is a 3-year project involving 13 partners from 5 countries. And each one of those partners has a specific speciality that matches the entire flow, let's say, of the project. So we have people that are specialized in the construction phases, but also in standardization bodies and in the implementation of, for example, the ontologies, but also of the UI platforms. And then we at UGent are part of the research node, let's say. The main goal, if we need to summarize the DigiChecks project, is that we want to achieve a digital framework for streamlining the processing and management of building permits. And the streamlining there is a very important word, because if we only have the data models, then it's indeed very difficult to streamline, because we don't want anyone to code permits. We want to have them. We want them to have a big, nice user interface, and then just drag and drop and these kind of things. But that involves an ontology in order to map it to digital building models online and CDEs, maybe linked data models, but also IFC, GIS, JSON data, heterogeneous data on the web, let's say. And the idea is that we have this top-level ontology that's able to hold for the permit part. Then this maps into the processes, so we want to allow the actors involved in the building process to devise their processes, and we also want to allow the authorities to build their rules, so to submit their rules to the platform and allow the other actors to say, okay, I want to apply for a permit in, for example, for ecological reasons. And then everything fits in the API. We have 3 pilots, each one considering a different part. So we have a civil engineering case, which is about infrastructure in the UK. We have a residential case in Madrid, and we have an office building case in Austria. And the idea there is that each of the three cases needs to be able to validate whether the platform is able to facilitate permits for pre-building procedures, like how to obtain a construction permit, how can we facilitate the contact between the applicants and the authorities, and then the specialists who need to verify the permits. That's preliminary. Then we have the construction process itself regarding safety, regarding waste management, etc., etc. And then, of course, each building has a very long afterlife, hopefully, where several, the installations in the building need to be certified now and then, and these things also need to be possible in the platform. This is a very broad scope. So that's why we don't think about the ecosystem as something that's a monolithic single point where everything is stored locally, but the framework is federated, which means that we provide the basis, but then third-party services can hook into it, and we have some kind of survival of the fittest idea where the best applications and the most specific building permits survive and get used the most. For this, it's very important that we use ontologies, the conceptual information models, that allow to map onto existing domain ontologies, such as the bot ontology, such as the product ontology, and so on. And for this we use, of course, W3C standards such as RDF, but also Shackle, and the DMN is the decision model and notation standard, which allows us to have this visual representation, which is also computer readable. I think most of you know about modular ontologies in the construction sector, so I won't dwell too long on this slide, but the idea is that because we have this federated ID, because we use the web, people can contribute to different topics, their domain ontologies, each cover a specific aspect of the building, and the idea of the permit ontology is that it's able to point at specific parts of the building, which can be represented using linked data, and then certify or allow certification for specific subdomains. So basically we have three main actors. We have the domain users who applies for the permit, who designs the building. We have the specialist who approves the request, and then we have the authorities who create the permits themselves, or the regulations, let's say, against which the permits need to be checked. Rather than devising an ontology that is able to capture each and every detail in the whole European Union, that's not possible. We have a very limited amount of classes, we have a very limited amount of object properties, which then local municipalities or people who work more on the field can then refine to cater for the differences within European cities, within each country, and so on. So for example, I don't know if it's readable, we have just classes for projects, for permits, for decisions, so that's all very high level. And in the end, this can boil down onto different, I have 1 minute left, so I will be a bit more quick. So to facilitate implementation of this ontology, the idea is that the end user should not know anything about semantic web. It should be hidden under a sleek interface or a visual representation. So that's why there are different notation ways. For example, we have the DMN notation, which allows to check the building model and just drag and drop. You can model the data exchange between the agents, so like the permitting process, but the cool thing is that you can also model the regulations, for example, accessibility, and then query the building model, drop it into the DMN, and then let it give you some feedback about whether this element is, for example, valid or not. I think the presentations will be published online. So there are some demos in the presentation about the current state of the Digitex platform, which hides, let's just, while I speak, I'll just finish up. So we have this platform which allows applicants, specialists, and authorities to work in the same interface and to send messages back and forth, allowing, for example, in this case, to request a new permit for bat migrations. I think the example is here. So it's oddly specific, but it's one of the yeah, I think my minute has passed already. It's very specific, but it's like one example to just show how the flow of data, how the flow between the different actors, which are also which don't know each other, can happen. So, and then the other, there are other demos where the ecologist, for example, approves and sees this is not entirely right, and then we have a justification by the applicant why it should be accepted nevertheless, and then, yeah, this goes on and on. So, thank you, and maybe there is room for more questions.
Anyone in the room with questions? Because I have a question myself, if you don't. So what I've seen in the demo, and I've got to learn from the project over time, is that there's a big focus on end user experience, right? So end users should be able to standardize without knowing the dorky things that we like to discuss here. And it seems to be kind of successful at that, at providing a good user experience. Do you know, or do you have insights in the development process? So to what extent are we able to ease the life of the developers of this application?
Mm-hmm. Yeah, I think that was one slide that I went over very quickly. I don't know myself how like the interface was built itself, but I included this slide, which includes a few libraries, which allows, for example, for the developer. So that's the part. Yeah, you don't see my mouse. That's the final part. And over the years, several libraries have been developed to, for example, this JSON format, which is JavaScript object notation, is very, very common. And there is this RDF serialization of JSON, which adds a context to it, allowing it to work on the web. So you have a context, you have a key value pairs, and the context provides the key with, or makes actually the key a URL, which allows to immediately hook on into the semantic web. So this is one very big step towards implementation for developers. And then I also included some other libraries that allow you to very easily query linked data on the web, even without a triple store, and just do federated queries and so on. So all these libraries could help to further implement linked data in a user accessible way.
So there's a toolkit already, and the developers who maybe weren't familiar with standardization before, do they know how to apply them, or do they need training, guidance in some ways?
There is, in my experience, still some hesitance, even so you have JSON LD, and the idea is that it's already way more oriented towards developers, but there's still quite a threshold to start implementing it. But for example, you have this other library there, LDFlex, that allows you really to program with like RDF things, and you have you can follow the tree, let's say, which is even, I think, more useful than JSON LD. So both from the library developers and the UI developers, there will be some gradual moving towards each other, and yeah, let's hope that the benefits will at some point outweigh the extra struggle.
I think we'll manage to do that. Okay. Thanks.
Thank you.
One second. Pablo. Sorry, Pablo is our next speaker.
Okay, I'm going to present something different because this ontology we call ontology for building simulation would be a new ontology, greenfield, because we are going to be working with entities which are not existent. They are mathematical entities. Okay. I am Pablo Vicente, and I work in the Building Digital Twin Association, leading the mathematical or simulation group. Is this way? Yeah. Why mathematical simulation for real time? Well, when we speak about real time, we can have like processes have milliseconds, seconds, 5 minutes, 15 minutes, 1 hour. If you are collecting information of the energy performance of a house during 1 year, obviously, perhaps the sampling is going to be 1 hour, okay? If we want to work in real time with buildings, perhaps 1 millisecond means historical files enormous, so it's non-practical as well. So we had to find the optimal place, and perhaps it is 5 or 15 minutes. So when we speak about real time, we are not speaking about the real time of PLCs or controllers. We are speaking about the real time of an operator, maybe, okay? Another point is that in construction, usually we don't have operators. We have no one, nobody there. So non-existing operators, clear. The idea is going from offline evaluation to response in real time, not only to evaluate, to respond. If there is any problem, we can respond immediately, okay? Sensors fail a lot, okay? And you are speaking about electrical or electricity sensors, very good. Any other sensor, pressure, temperature, CO2, rubbish, okay? That is the experience. We can improve maintenance because if we don't have an operator or if we don't have a supervisor, if we detect a problem, it would be very nice to be able to have a signal, an alarm, and to call in advance, you know, the technical assistance, not when the equipment is totally broken and it's, you know, burning. No. And another point very interesting is that if we put intelligence close to the sensors, close to the electronics, in the edge, we are avoiding privacy problem, okay? So they are independent devices, nobody is supervising the house, nothing in the cloud that could be assumed by the customers. We're going to be using something we call Symbot. Okay, what is a Symbot concept? This would be how is the home ventilation machine inside. This would be a mathematical simulation model. The mathematical simulation model has fans, has a recuperator there, have filters, and of course this is the physical component or equipment, and we have the same, okay? Fans, recuperator, filters. Okay, this would be the representation in the mathematical model of the house, okay? So this is the ventilation network, and here is that component which we saw before. So the symbol is like packing one equipment, and to use the equipment, boop, immediately in a simulation. So if fabricators could be supplying these functional models, could be very fast to have a simulation of the house. I call your attention because here we have fluids with temperature, of course, humidity, CO2, everything. So this is a very sophisticated simulation model, okay? And this is the typical interface of programs used for simulation, where you have the libraries, mathematical libraries. You have here all the components you're going to use, and this is the canvas where you are modeling your house, okay? And of course, that is a symbol, okay? So we right now, we have 2 projects in the BDTA. They are oriented to data centers, and we want to use the project like a sandbox for testing this vision of the symbots and the fabricators supplying the symbots. This sandbox about data centers, okay, we don't have humans, which is one thing. We don't have human building interaction, fine. So the limitation is the number of components. We have less components, more controllable. And the idea is to have these three developers already, to have some fabricators and associations like Riva and Nasrai getting the consensus at the same time we develop the components. Okay. So, the ontology, why? Because the idea is to be to collaborate with the developers of software who are in the market. So, if we can have an ontology, and from that ontology we can derive directly the libraries for those developers, we should be working in the ontology. Developers could be deriving construction the libraries from that ontology. Okay? So the ontology could be like the standardization of the components for all the software in the market, theoretically. Fabricators, they should go to the ontology, creating the component there, and from there all the software developers could be deriving exactly the same components. And we could be getting interoperability with SCADA systems, BMS, okay? We could have bin interoperability. We are thinking on an alignment with BOT at this point. And of course, we could have interoperability with sensors. That should be could be another discussion. Is well, the benefits of all of this. Okay, another day. So, the implementation. Well, we are in this initial step. We are deciding the disciplines, the entities, how to classify that. The object is to begin with a very smaller, controllable, and knowledge-intensive ontology with Protege. We are speaking about content, not only structure. We think that it's going to need an intensive management of maintenance because, of course, fabricators probably in the future they want to put new components or some components have to be revised, things like that. So we think that the BDTA could be leading that movement. Okay. We think that it could have a market value as well, because as soon as the ontology is the knowledge base of equipments in the market, developers could be using the ontology for some of the tasks of the software. Okay? And finally, the main need. And we think that the ontology could be a carrier could be a standard itself. So the ontology could be representing something in the market with a lot of value. And finally, the main need is the consensus. We are not going to be building the ontology without the consensus with the stakeholders' interest. Okay. And that's all. Thank you very much. Question? Questions? No questions?
Do we need to go into such level of detail, diving so deep into a sensor and making that an ontology?
Well, that's one of the things we have to solve. That is because we have a sandbox. In data centers, for example, when we began with the project some months ago, because they are beginning now, I think you have the image of what is a rack. In the rack, you have different servers. So a first problem was, do we have to consider each server, each computer there, or it is fine with considering all the rack? So the methodology we are implementing, you have to take decisions based on functionalities you want to get. So at one point, each of the computers, they have ventilators, so they are conducting hot air and cold air, and it is needed to have that component if you want to consider the flow of air, from one side of one corridor to another corridor. So in the end, we have decided, okay, we need a component representing each server. Okay, so all the decisions about which components and with detail level is the task we are doing right now. Okay? But of course, if you consider the chillers, for example, which are big equipment with a lot of valves and compressors, the degree of detail is very high. But the idea is that the fabricator should be providing that in the market in the future. So we are in contact with people working with the digital product passport, because this could be like an additional functionality of the product passport, where you are sending to the market all your equipment with the functional description there. Okay? It is important because if we don't have the SIMBOTs in the market available, this process is not economic. Okay? So to make profitable the use of simulation, mathematical simulation, we need the fabricators to be collaborating. Otherwise, it's not profitable.
Thank you, Pablo.
Okay, well, I'm Jorge. I'm from IDP. I'm going to be presenting, well, first of all, I'm not an expert in ontologies, so is it working? Yeah. Here I'm going to present a project that we did for the European project that we didn't have on the ontology for the integration process of tools inside a platform as a service designed for the designing of district heating network where we have electrical network and a heating network where we use a tool for mapping the entire district, the houses, the energy assets, and the piping for thermal and electrical. We use a tool for determining if we have enough energy flowing through the system to add a new house, to add a new restaurant, to add a new market, or this. That can calculate the energy from the source to every output. How is it working through the entire network? How much energy is in a node connecting different pipes and stuff like that. And then we have another tool that is optimizing the size of the energy loss through the pipes to determine the right diameter of the different pipeline that we have to install to have the correct flow. So for this integration process, we used two data groups. The first one was for the Binges toolkit, that's the one that we use to create the houses and the pipelines. And then we have the exergonomic optimization tool. This is the one used for knowing the optimized diameters of the pipeline to have the correct flow through the system. Here we use the GIS standard. This was simpler since we both use GIS to have like where the houses are located and the pipelines geolocations. And then we have servers. We have the information source to identify the components linked to the geometries. But the issue came up with the other one, with the saints. Since we didn't have standards, we had to accommodate the way they have the data structure to integrate into the platform. So it was a lot of back and forward. We lasted like 3-4 months just accommodating this process. So here, since they didn't have like open source standards, so we were entering a lot of problems with privacy. Like, okay, this information is private. This information, we cannot share this information. So we had to work around a lot of like hoops to get it done. Yeah, the objective in this project was to include these two tools inside one platform, so the user can use both tools inside one main ecosystem, digital twin ecosystem. So at the end, if we had a standardized ontology applied in the project, we would have like a single data model for both, since both both tools had some relationship between the data that they needed, so we could have shared this information and make the integration process easier and faster. We could have defined the different topologies, the integration services, yeah, this part. Reduce the developing time. Like I said, we lasted like 4 months. A lot of emails, a lot of meetings, a lot of time waste. Okay, and that would have looked something like this. Like we have like native GIS information, lines, points, and polygons, since the three tools shared the same. One that required more information from the nodes part, that is the one that connects the pipes, but the three of them could use the same information for the length of the pipes and the destination, the endpoints. And then we have like the transformation model where we transfer to the components, the ontology component. We have here the data structure. We have the scheme, a semantic component that we use for the filters to say we require the energy at node N1, so we can have the information on that node. And for example, get needs to have the optimize for a length pipe, so he can use that information and can also use it. Yeah, that's all. Anyone has a question? Okay. Have a great flight.
Thank you, Jorge. So again, we see a relationship between standardization, not just standardization in users, but standardization in development. And it feels like there's something there. And this is something I want you to remember and maybe think about, not during the next presentation, maybe during a coffee break. And I want to discuss about this with you in the session after the break. Between now and the break, there are, I think, 2 more sessions, at least one. I have to check the schedule, but Alireza is up next. Alireza is a colleague of mine at Semtech and also works for the BDTA, where he's currently working on the ontology catalog, important part or component in the solution to the challenges that we're hearing here. Alireza.
If I sit. Hello everyone, I am Alireza Ahmad. I work as a consultant in Semtech. I have a background in information management and digital transformation. Now I'm going to present you the Ontology Catalog project, which is a catalog for ontologies in the building digital twin domain. The agenda is going to be that I'm going to introduce the catalog. I'm going to present you why we need such a catalog, what are the requirements that we have considered, and what are the features that are going to satisfy those requirements. At the end, I'm going to discuss some discussion points to start gathering feedback from the community of experts, so starting with you, which are going to be very valuable during the development course of this catalog. Before I start with the catalog itself, I'm going to explain where the idea started. So it all initiated in the last BDTA 4. BDTA was concluded with few remarks. That those remarks include that the need to define principles for interoperable ontologies, the need to improve interoperability between the current ontologies that we have and reduce the redundancies, and also to achieve those, they need to have a catalog of ontologies in the domain of interest that we are discussing. In that Congress, let's say a plan or a roadmap was defined for the next 3 years, starting from this year to develop the first version of the catalog, and then in the course of the next years to improve it and to add additional features and toolkits for improving the, let's say, the usage. So first, what is the ontology catalog that we are considering here? Basically, the catalog is going to serve as a central hub for the ontologies in the building digital twin domain, or in other words, it's a collection of ontologies that are available in the domain that will enable users to achieve certain things that we're going to discuss. But before that, why do we need a catalog? So we need a catalog to be able to enable the users to share the ontologies that they develop, or to explore available ontologies in the domain and to see their use cases and to be able to access those ontologies, and finally to be able to encourage the usage of those ontologies among the user groups and among the industry and the domain of interest. But when we are talking about the users, which category of users we are considering for such a product, and those users are going to be first the ontology developers, of course, the people who are contributing to creating ontologies in the relevant area, which is the building digital twin domain. It could be both from the academia and both from the industry as well, the industrial parties that are, let's say, contributing to such a standards. Then the software developers and software providers. So it's gonna be a hub also for software developers to get to know the ontologies, let's say the usage and the use cases they have, and also hopefully to be encouraged to implement those ontologies in their softwares for the users to use. And finally, the ontology users. So the users could use ontologies for different purposes to gain the benefits. Let's say that if organizations want to use ontologies for data exchange or for data validations, then this is a place to use ontologies and to find ontologies. And we have divided the project into 3 phases. The first phase, which is the phase of interest for today, is the MVP, or the first version of the catalog that we're going to develop and we are developing, which is basically a catalog of ontologies with the necessary informations and basic guidelines for the community. Then in the phase 2, we're going to gather some feedback from the users on the phase 1, and we're going to improve the features of the platform. And in phase 3, we're going to introduce more advanced features, like being able to query those, let's say, those ontologies on the platform, and some other advanced features. So I have added in a slide. I want to keep it short. I have added this slide with the objectives of each year depending on the plan, based on the plan that was developed in BDTA. I don't want to repeat it, but basically these are the objectives that we have considered for those, let's say, 3 phases. Then, so it's important to know that we have done analysis on the requirements, on the overall requirements that we can consider for this platform, and we selected, let's say, the top requirements for the MVP phase that we see them necessary for let's say, for this platform to be used and to be useful for the users. So what are the requirements? First, we want to enable users with use cases or with problems to be able to find ontologies relevant to their use cases and to use them. Also, we want to enable software developers to find related ontologies to implement in their let's say, software applications. As someone active in this domain, we want to enable you also to be able to have a place to explore different ontologies for getting ideas, for aligning ontologies together, or for, let's say, getting ideas for the roadmap of the ontologies that you are, let's say, developing, and also to have a place for the community to showcase their ontologies and to be able, let's say, to encourage others to use these ontologies. And finally, to connect the creators and all the users of the ontologies together and to be able to act it as, let's say, as a focal point for the people active in this area. And the features that we have considered, so this is it seems to be a short list of features, but let's say these are the critical ones that we see needed for the first phase. First, we need to have a list of available ontologies in the let's say in this domain. I'm going to discuss what are the criteria that we can consider, and also I'm gonna put some discussion points that we can continue later on after this conference. Then we're gonna store the details of each ontology. So for the users that want to get familiar with the ontology and want to be able to use them, there are certain amount of information that they should have before they get to start those ontologies. Then we're gonna enable search functionalities on the platform so the users can, let's say, explore ontologies and search between ontologies based on different criteria and based on different informations. And then we're gonna develop some guidelines and tutorials for on the platform for the users. This point could, let's say, take some time and could be elaborated during the development phase, because we have to see that from which aspect of the users we are looking at these guidelines. So it could be the guidelines from the developer side, ontology developer side, that we could define the principles that we talked about, and we could share the principles here on how to align ontologies before defining, before developing a new ontology. Or as others mentioned, so for software developers, as also Bram mentioned, so software developers are not usually familiar with ontologies, but they are familiar with the development side. So we could share some guidelines on model-driven development, how to develop a software incorporating a model or an ontology in the software, and how to show the benefits of that for the software developers as well, or from the, let's say, aspects of the other group of users. So this could be, let's say, also a beneficial point to gather, let's say, interest to the platform as well for the community. So these are the features that we have considered. Then I put some discussion points that maybe hopefully we can start some discussions here, and then we're going to reach out to you with some, let's say, further follow-up for gathering input from you. So there are a few factors that, let's say, we can think about them together when we are developing such a platform first. So for the very first question is that what is the criteria for selecting ontologies to share on the platform, right? We can see it from the horizontal, let's say, side that, okay, what are the subdomains that we want to consider? So permitting, energy management, environmental modeling, are they relevant to building digital twin? Are we going to consider other subdomains? This is an area that we can discuss with the community. Second, the metadata that we want to store for each ontology. So what are the minimum information required that we see the users need to get familiar with those ontologies? So from the creator, from the publish date, from the update date and frequency, from the use cases that those ontologies can be used for, or from the applications that they have implemented those ontologies. So then it can act both for us, like as a catalog of ontologies or as a catalog for the applications that they are using some ontologies in the domain of interest. Then based on those, we're going to develop a form, and we're going to share it with you and the community to gather the ontologies available in the field. Already I've seen that, for example, in DigiChecks, or the Judith has presented, also they have done extensive research of the available ontologies for permitting, or the one that they have provided. So these are the first input. We will share a form with you also to gather the available ontologies from your side, and then we can also list all of them together, and then we can start publishing the first ontologies on the platform. And also, it would be nice to gather some feedbacks on the guidelines that you see necessary to publish on the platform. So I mentioned a few for ontology developers, for software developers, or some for some other use cases. It's nice to gather also some feedback if you see that some guidelines are necessary to encourage the community from different perspectives to start using ontologies or to improve their usage of ontologies. That's the presentation. I tried to keep it short. And so let me know if you have any question to discuss.
Thanks for the presentation. I was wondering whether you consider for this platform to like as it being a collection of the ontologies themselves, or merely as like just a list of the namespaces of the ontologies, so that you can just point to them, right, and then allow your UI to just fetch the data from where the ontology resides.
Right. No, so the goal is not to duplicate the data and to refer to the sources where they are published. Later on, if there are ontologies that they are not existing in a published, let's say, space or in an available endpoint, then we can think about, let's say, developing some endpoints for those ontologies. But the goal is not to duplicate and to keep the reference to the source.
So it's some kind of index, yeah.
Some kind of index that acts as a hub for all the ontologies that are spread all over the place and all over the academia or industrial spaces.
Okay, thanks.
No worries.
While I'm walking there online, also one ontology, EP4SES, has been submitted, so I'll forward that one to you as a first recommendation.
Oh, that's nice.
Okay, the question is the following. Are you plan or is in your roadmap to connect this catalog with existing catalogs like linked open vocabularies?
So we haven't included, but we haven't, let's say, considered connecting it, but we could use those ontologies available on those catalogs, because the goal of this catalog may not be 100% aligned, like the domain that we are considering, but we could use the ontologies available in other products and link it to those catalogs.
and also the other way around, because maybe you detect some ontologies that are not in those catalogs, and you can fit them. Yeah.
Exactly. We can keep the reference and connect into those catalogs. Exactly.
Well, thank you for presenting Alireza. I definitely think you should speak to Judith and find her research results and incorporate them in the catalog in some way.
Definitely.
Thanks.
No worries.
And our next speaker is Mr. Colin Boche.
I've got notes. I'm going to sit down, I think. I can take that. Thank you, and hi everyone. So I'm Colin Boge from List in Luxembourg. Been working as a research associate for about 6 years. Previously, I've done my PhD around the subject of crowd simulation modeling and fire evacuation using ontologies together with Tom Beach. He's here today, so one of my former mentors and professors. So it's good to see such a big crowd. I've been working on ontologies since my PhD, so it's about 10 years now. It's a long time. And I've been publishing a few things on digital twins since 2020, so hopefully you've come across some of my publications. And this is actually part of the work that I've published and presented this year in at Linked Data and Architecture and Construction, LDAC, that was in Bochum. And it's related to the Meta Buildings Labs project, hence I have the t-shirt here. And if you haven't seen my demo, there might be some time later today. I can show you exactly what this is. So it's about defining the semantics for digital twins of facade components testing facilities. It is a very applied use case, and the role of LIST within the Meta Building Labs project is to provide a digital twin platform, or at least an interface, starting from a demonstrator, potentially going to the market for a digital twin of this facility. What makes this use case very special is that it's not a normal house. It is a house embedded with a lot of sensors. It is very special in the sense that it's a test bed. It's a testing facility. Meta Building Labs will provide a network of these facilities across Europe so that people that may not have access to testing, standardized testing and certification of materials for new facade components such as windows or insulation materials will go through the Meta Building Labs Association. They will test their components, and they might also be able to have access to real-time data according to, they're paying for the service of testing their components, and therefore they might also have access through the digital twin of all the data that is being generated to follow their testing procedure. So this is what it looks like. That's a photo of the one built in Valladolid in Spain, or close to Valladolid in Spain. I'll show you in the next picture, this one. Yes. This is what it looks like in the BIM model. Okay, this is what it looks like in reality. We try to come as close as possible, but what you see here actually is the 3-cell version, but we also have the BIM for the 2-cell version. They built the 2-cell version in Valladolid. These are identical cells, completely insulated, isolated from each other, and there is a guard zone. So we'll look at the plan view here. There is a guard zone that also tries to keep everything conditioned. So that means that if the temperature or humidity changes, there's equipment inside these spaces to make sure that they don't really change, so as not to compromise the validity of the test. So what we're testing, so what you see there, different scopes. So I guess what makes it special, again, in terms of a digital twin, is that we don't have just one digital twin. We have multiple digital twin scopes or multiple layers. We have the digital twin of the building itself, so the facility. We have the digital twin of the cell, and we have the digital twin in a way of the facade element. The facade element, you see the sensors in red. Those can be different types of sensors at different moments of testing. So usually what happens is that someone buys the service of testing for a couple of weeks or a couple of months. They put the element on the facade with specific sensors for the type of test that is being carried out. So you see that there is a disconnection between, or at least certain sensors are moving, let's say, and changing, whereas the sensors in orange and in yellow, for example, they're more or less static around the building. So we are monitoring things such as temperature, heat flux, humidity, rainfall, depending on the types of tests. And these need to be monitored and strictly controlled and recalibrated at different times. We've published the process of digital twinning of this concept around the O3BET, around testing facility, I think last year in EC3. So you can also find all these papers. They're all open source and all the diagrams, so don't worry about it. I have a reference at the end. The idea was to digitalize and streamline the modular testing process, to monitor the testing environment, to simulate different scenarios, and to explore design options, models, and different applications. I'm trying to make it relevant for today's workshop, and I'm going to express the specific needs that this has. So I've already tried to explain what's happening more or less in reality, so we tried to represent this real process using ontologies as much as we could. Also, our aim was not to create a new ontology, because there's plenty of ontologies out there. So what we did is we tried to find them, and we tried to align them to our needs as much as possible. So we split them into procedural, spatial, equipment and sensing, measurements, and virtual system boundaries as some sort of a domain, some sort of, a way to catalog, or let's say, what we're doing here. So procedural means things that are part of the process, the testing campaign itself, the different actors and the users of the digital twin. The spatial represents the facility spatially, so something like bot fits very well in here. Delimiting, the monitoring, the testing, and the boundaries. So I've shown you the cells, I've shown you the different areas and the spaces, right? The equipment itself, the measurements, okay, so the types of properties that are being measured, temperature, humidity, heat flux, and the virtual system boundaries. So what do I mean by virtual system boundaries? I mean that I could have multiple digital twins. I have a modularity way of testing. I have different connections within different contexts of the digital twin instances. There is one for the facade, one for the cell, and they also may not live together at the same time, because when you move one of the components of the building, essentially you are undergoing some sort of accelerated life cycle. Imagine that you're moving a window from a building and you're placing another one inside. So you need to update this. It's quite difficult. Here's a list of ontologies that we have, okay? So we restricted ourselves to this. We haven't finished the process. We're looking at bot, that covers our spatial needs, looking at SAREF core, that covers our sensing equipment and measurements. We've also considered SSN and SOSA, which is more scientific, by the way. SAREF is a lot more towards IoT, so you can really, I think it's more towards devices and spatially dividing it as more towards IoT, whereas SAREF and SSN is more scientific measurements. It also has sampling and so on, which might also be useful. Then we looked at IFC because we needed to have a BIM and to be able to visualize and to give it some sort of geometry. But I haven't really used IFC in a long time, so I've restricted myself to bot, but I have taken some elements from IFC. And I'll show you the schema later. Then prov, so the provenance ontology, concepts such as processes and actors. There's a new ontology out there that I came across called Noria, developed through a French project together with Orange, the telecom provider, where they look at digital, I'm not sure if it's specifically digital twin systems, but they had things such as fault detection and diagnosis in IoT systems. So for us it was relevant because we want to detect when something is going wrong, more so than in a normal building, right? Because we're compromising the test and therefore we're compromising the money of the client. And then things to represent properties, we just looked at props. However, I wasn't really able to find, although that is the namespace, I'm not sure that it's valid anymore, so you might have to contact the people in charge of this. Okay, I don't think that you guys can see that. But that is the schema. I encourage you to have a look at the paper. I'll show you a link later. I think I'll have zoomed in images. And I'm just going to go through each step. So just to explain what's happening. So here's how we use the ontology in a very simplified way. Using prov is in gray. So I've got my managers or my clients, and these are stakeholders or organizations. And then I am describing processes, a prov process, which is a campaign. So a campaign is basically a delimited amount of time of testing. I'm testing from January to March. And in that span of time, one of the cells will be attributed to one of the clients. The other cell might be attributed to the same client or to another client running a different test or a different campaign. There might be different contexts in the future, we're not sure. We could also have one campaign running on multiple buildings for the same client, and we might have to converge them at some point. Then we're going down into bot, so into the spatial side of things. So we have bot building, a site, building, story, and space, right? So it's quite easy. You've seen this a lot of times. And then you will see that I have added there element, and element could be bot element, and it could also be the IFC built element. Because we wanted a way to represent the sensors and the built elements. We wanted to have them as a geometry, so the sensor is a geometry in IFC and then bot is an element, because I believe there is no sensor in bot. Is that correct? So for me, in order to be able to click it and to use it as a sensor and as a little box in the BIM model, I had to make this sort of artifice, because I need to distinguish between them. So then we're going down into Saref, which is in yellow. So we've got devices. So a device could be a sensor, an actuator, or other things. Also a device, I think it's an abstract class, and it might have multiple sensors. And the sensor, in our case, one device is one sensor. So what do you mean by one sensor? One sensor usually measures one property. One sensor measures temperature, another sensor measures humidity. If you have in your house, in your home, certain devices that you can buy out of the box, it's a device with multiple sensors. It's a device that measures humidity, temperature, noise, right? And for us, it was important to distinguish between device and sensor, for example. And so this is more or less the workflow of how we're getting the data, the real-time data. And what I haven't shown you is fault management. So with the NORI ontology, we're still looking into that. When we are detecting anomalies, that will raise an issue, and that issue could be a ticket that could be forwarded to the manager of the facility. Okay, so that is the use case relatively briefly described. I'm not sure how much time I have left. Then there was another challenge that we were facing with regards to how the data is transmitted. So, okay, we're putting everything in ontology because we're connecting BIMs, we're connecting IoT data, the other contextual data. We need the ontology to construct the context, okay? And then it was also one of our motivation to provide this context of testing to the client. Since the client is paying for this whole process in an adequate context, it might be useful, and also for future research or for future references and for future history or historical data, to have the context described and survive. And so here, I guess we're trying to describe in terms of a digital twin, that we create a campaign. The campaign relates to the digital twin of the facade element. When the component, the physical facade component, is placed on the facade, the digital twin of this facade element is online or is alive. And then you want to take it off, the element disappears, and then all the sensors and the context related to that element disappears. But the building is still there, and then it will be replaced by something else. So here we're following the process of this facade element. So as I've said before, it's the building itself is experiencing some sort of an accelerated life cycle, right? And in that sense, if you're looking at the context of normal buildings. And so we want to capture in one campaign and to contextualize all the data for the client as one maybe graph or as a JSON with all the concepts that we mapped from the schema, so that he might be able in the future to decipher what happened, such as the spatial context of the facility, the sensor data that we monitored for the client, together with any testing faults that might have happened or issues that maybe were raised, along with maybe the comments from the facility managers to say, yes, this was an issue, or this wasn't an issue, and so on, or this hasn't compromised the test, and so on. And to do so, we kind of artificially have to go against the principles of linked data and ontologies and start each campaign as one separate graph. And we're also trying to share resources where possible. So at the bottom, you see that there are certain shared resources, such as the sensing properties, so there is no issue for sharing across the graphs, things like temperature and humidity, but there is an issue of sharing data from one client to the next. They shouldn't be able to see each other's data from each other's facade element testing or cells, so we are constructing the context, let's say, based on that. So there is some sort of modularity of graphs, but it goes a little bit against the principles of linked data. So, but we might have to, yeah, we're thinking how to solve this, but for the moment it looks something like this. And then I've got some examples, but I don't think it's worth going through them. This was also what I've shown in LDAC. how we are linking the two graphs. So here you can see that the organization is mentioned in one of the graphs, but then in the other graphs you have data that is missing. So again, you can find this in the paper. It's taken from the paper, the diagrams, and this is some of the Sparkle queries. We are using GraphQL to federate data together with GraphDB as a backend, and the demo last year looked something like this, and then you can see it again on the big table outside. And yes, I think I might stop there. I have tried to make conclusions for this workshop. So the O3-bed digital twin has a very specific needs for context creation, which lacks certain ontologies such as testing and alerts. So we looked at this Noria one, but I'm not sure. It's a very large ontology itself. It's for IoT, but it's not specifically for digital twins. And it's a highly customizable use case. So it's a bit different from buildings, from infrastructure, and so on. But I think it's relevant because you never know what sort of buildings you might have in the future. In terms of alignment, so how we did the mapping, it was difficult. It wasn't something automatic. We used a sort of systematic, manual approach. We looked at each ontologies, we read, we tried to understand, we applied it, we didn't like it, we changed it. I mean, that's basically what we had to do. There's many choices, there's many ontologies out there. There's a lot of use cases that explore digital twin cases already. And in our case, I'm going to go back quickly to this diagram. When we couldn't, there were some times when we couldn't really connect between the ontologies, so we had to come up with certain properties. So for example, you see there between built element and sensor, I have described, I believe if it's in white, it means that it's our property has device, okay? And there might be a few others. But trying as much as possible not to create something new, but just to connect what already exists. Yes, so query GraphQL. We use GraphQL for the first time since we moved from Sparkle. It's quite flexible. So now this maybe goes back to your front end and development. I think GraphQL is very useful because the software developer will ask specifically what it wants from the graph, from the schema. However, we were experiencing a very interesting limitation of GraphQL, that in GraphQL you can only query one contextual graph. Whereas in Sparkle, you can query and you can unite. I'm sorry, I keep clicking through these. You can query and you can unite multiple graphs at the same time. So here you see one query above with two graphs included. So I find everything, and where I have it from the default graph, I can see two, and then from the other one, I can see one. Whereas in GraphQL, there is no way that doesn't allow you to put multiple graphs in the same query, which means you have to query twice, maybe. Yes. So sorry for going over, but thank you very much.
Thank you very much. Provide a lot of useful insights, and one for me actually is that so we don't necessarily need the semantic web stack for graph-based ontologies. However, for some use cases we do, or for some specific components of applications and Exchange we do. Is that a correct interpretation?
You're referring to the stack of typical semantic web technologies. Indeed. For going from backend to frontend and so on. I think from that we've just used ontologies as a schema of graph database and querying via Sparkle or GraphQL in this case. So we haven't used the others, yes. Because we're facing different limitations, especially with sensors. People like to store things in time series. And time series is a different kind of database. And then we've also experienced in previous projects where we have a lot of data that is changing in graph databases. To do Sparkle to delete something and to update and create all the dependencies around it is quite difficult. When you just have your BIM model and you export to a graph and then you use that as a static component, let's say, that works just fine. But as soon as you're dealing with IFC tasks, for instance, for scheduling, and you start putting a task in and deleting it or modifying it because, with scheduling, time moves on and objects disappear or stay redundant, you might end up by the end of the year with 1,000 tasks which you have to query and they all come in together, and so it's becoming slow.
Right.
So I think that a pure semantic web technology stack solution for any system today may not be the most optimal, especially for industry.
I think that last bit of the sentence summarized perfectly, right? So we have seen so far that different users need different things. The one needs an extremely detailed ontology on sensors, and the other just needs a sensor to be there. And the same way around some applications or some components you're building might need the one piece of technology in the stack, and the other needs the other. That's a very good lesson of this afternoon so far. Are there any other questions in the room? One in the back.
Yeah, thank you. I think your wish from your beginning of your presentation has already been fulfilled, because I cited your work in my PhD thesis.
Great.
So my question is, since you have a very sophisticated work on digital twins, did you ever consider to use or to integrate your digital twin into a cyber-physical system? Because I think you have been talking about messages. This could be sent to the vendor or to the provider. The next logical step would be, for example, to couple these with actuators, with a feedback loop into the real world. Did you ever consider this?
Okay. It's a very thin line between digital twin and cyber-physical systems. I think that a cyber-physical system would be something closer to, well, at least in my opinion, manufacturing or things that are more fine-tuned or at smaller scale. I think that digital twin probably came out of cyber-physical systems, but okay, we can discuss etymology later. I guess for the case of O3bet, and yes, you're right to point that out. In our case, I'm going to try to go back to, okay, you see there that I have sensor and actuator. So we tried to be a real digital twin on the physical side. The problem is that we rarely want to actuate anything in this context. However, the things that will be actuated, if necessary, and that probably will happen as a rule-based actuation, will be related to the conditioning of the zones. So the thermal zone, that is the guard zone around in gray there, and also within the cells, there's radiators and ventilators that need to have a set point temperature, for example, and humidity. But does that make it a digital twin? You know, I don't know. Does that make it a cyber-physical system? We haven't really thought about, or we haven't reached that point because we haven't actually had a real test. We are only doing samples at the moment, and we're testing the pipelines and so on. There it is.
So far, if I may, at least as we see at the BDTA, a cyber-physical system is not meant to track the life cycle of these things, which is mirroring. Okay, it's trying to analyze, optimize, actuating, okay, in the process to get it, optimize it, okay? But if you are replacing what component of this system, okay, the cyber-physical system is, okay, you can obviously update it, okay, and but if you have the process to keep it updated, okay, and this is usually the most difficult part, how you keep track of all the changes, and even more when we are talking about buildings or bridges, or okay, how we keep track along the life cycle, how we start with the permits, how we start with the design, how we manufacture. Okay, so I think that Jonas will talk afterwards in how we keep track of what is in the construction site. Okay, the changes that are happening each minute. Okay, so I don't know the real time where we could put there. Okay, so how we keep track of that. So I think this can help it to draw the line. Okay, and how we can differentiate inside.
I'm not sure if I answered his question though, but because I see him a little bit. But we can have a chat after. Yeah.
In any case, I think it's fun. Yes.
I just want to compliment on that. There is a lot of sophisticated equipment that you don't see here. A lot of wires in this diagram, and actually most of the time things are maintained manually, because there isn't really an option. You know, the sensor is not going to fix itself, like Pablo said before. And yeah, it's going to be very challenging, especially for these facilities. But for smaller use cases, or for simpler, let's say, use cases of a normal building that you're monitoring, like this building here, or monitoring a construction site, maybe you don't care about all these little details. I'm not sure to what degree. What is the level of, I really like the slide when Pablo said, what is the real time that you need, right? Do you need every millisecond, every second, every 5 minutes? Maybe you just need to know when it changed, because if it's the same temperature for 20 days, you don't need to read it each time, because you're consuming energy reading it, and you're also destroying your sensor by taking captures very often. But yeah, that's probably out of context at this point. Okay.
Pablo, last question.
I really like the project first, and I would like to support the idea that the right ontology for the right purpose and the right observation time, all of that. But it is fantastic to have measurements in one side, and to support the measurements, to have two sources of information, to be robust with the information you provide to the client, and to be safe, because you have like all the information available in one platform, well and tidy and well kept. So congratulations.
Thank you.
Perfect. Thank you, Colin. Okay. This concludes the first half of the workshop. We managed actually to catch up, make up some time along the way. So my proposal is that we do the coffee break for now. We see you all back here, please, at 4. Take someone along who isn't enjoying another session, because after the break there will be the 2 last and best presentations, or equally good as the other ones. I'm sorry, I can't diminish. And we will have a discussion on basically on the questions and the small discussions we've had so far, and take a next step in that. So see you after the break.